Thank you. All right, so I actually have an intro slide about myself at some point, but she just gave that slide for me, so I might just let her do the rest of my talk if that's okay. Yeah, so like Caitlin said, my name is Ryan. I am a postdoc at WashU right now, so not too far down the road from you guys. Just so you guys know, after I'm done, you're welcome to come up and look at anything I've got up here. I've got a couple of meteorites you can touch and hold if you want. If you take them, I'll come hunt you down, but they are up here, so we got lots of cool pictures and other various things, and I'll talk about some of it throughout my talk. So I'll just go ahead and get started. So I usually like to tell people when I'm introducing myself that every little kid wants to be an astronaut, but I never outgrew it. So that's kind of my story. That's why I'm doing what I do now. I really love space travel, exploration, everything like that. So ultimately, I'd love to be an astronaut one day. In the meantime, I study the moon, and I very much enjoy it. So this is kind of exactly what Caitlin just told you. I wasn't sure how much you guys would know about me, but I am a postdoc at WashU, so I did my PhD there. How many of you guys knew that WashU had an Earth and planetary science, like really good program? Not many? Yeah. We actually have the second largest collection of Apollo moon samples next to NASA. So lots of cool things there. We're always open to giving people tours of our department. We have a model of a Mars rover, if anybody's interested in seeing something like that. We have a lot of really cool things. So if you're interested in something like that, just get a hold of me. I'm happy to organize. We have several people who work on the mission that just got to Pluto. How many of you guys saw that on TV? Yeah, so we have a lot of people who are working on that right now. We have people who are driving the rovers on Mars. We also have people that are studying the moon, like me, as well as other things more focused to Earth. So again, yeah, I did my bachelor's degrees in Florida, so I got 2 degrees, physics and space science. While I was there, I lived an hour away from Kennedy Space Center, so I did 2 of my internships out there, studying the effects of rocket exhaust on the moon. At the time, we were planning to go back to the moon, so I was doing a lot of work with that. That was put on hold, but my work kind of continued, so that was exciting. And then the summer before I moved out here, I worked on a proposed mission to go bring samples back from the moon. It has not flown, it's being reproposed, but that was also a really exciting time. I did that out in California. We designed a camera that would go in orbit around the moon for the mission. And then now I am on the Lunar Reconnaissance Orbiter Camera team. How many of you guys have heard of the Lunar Reconnaissance Orbiter? There's just a few people. All right, the husband doesn't count. He hears me talk about it all the time. And I'll talk about that here in a minute, but before I kind of get into the Lunar Reconnaissance Orbiter, I want to talk about why we would even consider sending humans to space, because that's kind of ultimately where this talk will go. So there's a lot of reasons. First off, we have a lot of unanswered scientific questions in space about how our planets formed, how they evolve. I could spend an entire talk just talking about that. Also resource harvesting. There's a lot that we can actually get from the surface of these planetary bodies. We can mine them for different minerals and resources. We can also create fuel in space, which I'll talk a little bit about later. Humans are way more efficient than robots. Some of these things you've seen the Mars rovers do, humans could have done in a fraction of the time. While these robotic missions are great and they really tell us a lot, humans are just way better at doing science and exploration. We can develop technologies. A lot of the products we have today, for example, tennis shoes, those kind of things were developed by NASA for the space program. So there's a lot of new technologies that are developed by sending humans to space. We can also build permanent or semi-permanent architecture, so we can learn to live in space for longer periods of time, to find out if we're alone. So this is a big question. Is there other life out there? We might not find out till we go out and look for it. And then finally, just exploration. So exploration is really ingrained in who we are as human beings. How many of you guys have gone out and explored a forest or your backyard or anything? I mean, I know I have. That's one reason I'm really interested in space exploration. I mean, we have people like Christopher Columbus, who set out to find new trade routes to China and instead discovered the Americas. Lewis and Clark, who set out to map the western portion of the United States. They discovered 200 new plants and 72 new Indian tribes. And then Ferdinand Magellan, who circumnavigated the globe. So these people set out to explore, but along the way they made really important discoveries that have shaped us as human beings. And so this brings me to Astronaut Explorers. These people do the same things. They go They're brave. They go to these places that we haven't been, and they bring us back samples or other scientific discoveries. So that's why I want to talk to you about the Lunar Reconnaissance Orbiter today. Sorry, I forgot I had this slide. So let's go through this first. I have milestones in human spaceflight we're going to run through real quick. So sorry, the red's a little hard to see, but we had our first man in space, Yuri Gagarin, in 1961. The first American in space, Alan Shepard, in 1960, I guess the same year, sorry. Forgot that was around the same time. The first woman in space was Valentina Tereshkova, another Russian, in 1963. We had our first spacewalk in 1965. We had the first trip around the moon by Apollo 8 in 1968. And then the first steps on another planetary body, which was Apollo 11 in 1969. The first space station crew in orbit was in 1971. We had the last steps on a planetary body, Apollo 17 in 1972. The first international manned space flight, so astronauts from different countries at the same time, was in 1975. Our first space shuttle launch was in 1981. We had our first International Space Station crew in 2000, so over 15 years ago now. Our first space tourist was in 2001. Our first commercial space flight was in 2004, and then our first commercial spacecraft in orbit was in 2010. And I want to highlight this one. So 1972 was the last time anyone stepped foot on another planetary body. That's a really long time ago now. So I would like to see that change hopefully soon. And so this is one reason that the Lunar Reconnaissance Orbiter was actually designed. Now I'm going to start referring to this as LRO because it's kind of a mouthful, just so you guys know what I'm talking about. So this is a mission that is currently still in orbit around the moon. LRO was launched in June of 2009. I actually got to see it during one of my internships. Had no idea at the time that it would become such a big part of my life, but that was kind of an exciting thing. This mission was designed to gather data to help scientists and engineers plan NASA's return to the moon, both with robots and with astronauts, which was the plan at the time. So there are several different goals that this mission has. They're always changing depending on what we're discovering. So I've just listed a few key ones here. Identify safe landing sites was a priority. So they had about 50 sites that they were looking at to start with that were potential human landing sites. But ever since then, they've started looking at other places as well. Identify potential resources on the moon, and then characterize the radiation environment so we know how safe it would be for humans to be there for a long period of time. Improve maps of the moon's mineralogy, what is it made of, search for water ice at the poles, and then determine the impact hazard, so how many objects are impacting the moon and how often. So LRO and its discoveries are very important because they help us enable a sustainable human exploration program. So the discoveries have revealed locations that are really important for future astronauts to work at and live at. The moon is really important because it's the most accessible science and exploration target in our solar system. It takes us about 3 days to get there, so that's not too bad. It takes longer to get there if you drive somewhere across the United States. So I'm having trouble reading from my little font. So we can also address key solar system science questions by working and living on the moon. There's a lot of things we can do there more efficiently than we can do on Earth, especially because there's no atmosphere in the way. Again, technology demonstrations, there's a lot of new technology that needs developed in order to work on the moon. And the moon is actually a good stepping stone to Mars. So learning to live there and work there will enable us to eventually send humans even farther in our solar system. All right, so back to LRO. I'm going to run through the instruments on LRO really quickly. This is basically a remote laboratory in space around the moon. We have Crater, the cosmic ray telescopes for the effect of radiation. This does exactly what you might think, and it characterizes radiation on the moon. We have Diviner. So this one actually does several different things. It takes thermal measurements. It looks at the abundance of rocks on the moon. It also does some mineralogy type studies. LAMP, the Lyman Alpha Mapping Project. So this one looks for ice and maps the surface in the ultraviolet wavelength range. You'll notice that NASA really likes acronyms, so these all have cute little names. We have LIND, the Lunar Exploration Neutron Detector. So this one searches for water as well. Then we have LOLA, the Lunar Orbiter Laser Altimeter. So this one creates products like this guy, which measured slopes, elevations, roughness, and then topography. So this colorful globe of the moon is showing you differences in elevation. So the reds are really high areas, and the blues and greens are lower areas. And then we have LROC, the Lunar Reconnaissance Orbiter Camera. This is taking the highest resolution images of the lunar surface that we've ever had, which is kind of what I've got displayed up here for you guys to look at here in a bit, and you'll see plenty of pictures throughout my talk. And then there's Mini RF. This is actually more of a technology demonstration, like I've been discussing. It actually uses radar to look for water under the surface. So they've been kind of using this one just to test out this technology. It's actually off right now for budget issues, but they're hoping to turn it back on soon. And this is LRO when it was being built with all the little instruments pointed out. Oh, yeah, so I'm going to focus on LROC for the rest of my talk. You can ask me about the other instruments. I probably won't know much, but if you ask me about LROC, there's a good chance I'll be able to answer your question. So LROC is actually a system of 3 different cameras that take images of the surface. So there's 2 narrow angle cameras shown here. This is a hammer for scale, so they're pretty big, but these take the highest resolution images. They're about 0.5 meter to 2 meter per pixel. And then we have the wide angle camera, which is just one camera, and it takes images at a resolution of 100 meter per pixel. And this one can actually can create color images. So I'll talk about the color image here in a bit. That's pretty neat. So I focus mainly on the narrow angle camera because this enables us to see much smaller features on the surface, which are what I'm interested in. Before I talk anything about my work, I want to run through, kind of show off the camera a little bit, and then talk about some important discoveries that LRO has made. This is a wide-angle camera image of the moon, so just kind of showing off the really high resolution, beautiful images that we can take. So this is the near side, so this is the side that you guys are used to seeing when you look up in the night sky. Here's 4 different views of the moon. We've got the near side here. Here is the far side that we never see, and then the east and west sides. This is what we call a central peak. So this is basically a mountain in the center of a crater on the moon. This is in Tycho. I have a printed out image of this up here if you guys want to look at it in more detail later. And I want to zoom in on something on the top of this. So this boulder right here in the middle, that's the size of a football field. So this is a very large mountain on the moon. And it's in the middle of a very large crater. So these are just kind of examples of some of the really neat features that we take pictures of. These are rays from a crater. So this is actually ejecta that's been distributed after something impacted on the moon. So again, another really beautiful feature. This is kind of like what I showed you here, except this was actually created using the cameras because we can get data on topography from those as well. So this is the far side of the moon again. You can see it's really got some really rough areas that are really high, some really low areas. And then here's the near side. It's quite different, you'll notice. So it's a little smoother and flatter. And then this beautiful image was taken recently. So this is actually, this was a narrow angle camera image, so it's very high resolution. But the narrow angle cameras don't take color pictures. So what we did is we actually imaged, so both cameras are taking pictures at the same time. So the narrow angle camera took this image in black and white, but we had wide angle color data for the Earth. So they actually stitched these together to make this really beautiful composite image. And these are true colors. So this is basically the Earth from the moon. It's really beautiful. We don't just take pictures of the moon, it turns out. And then I will talk more about this a little bit later, but this is the Apollo 11 landing site. This is how good our camera is, guys. If you look here, this is the lunar module that Neil Armstrong and Buzz Aldrin touched down in. And these are the footpads, these bright dots. I don't know if you guys can see it in the back of the room, but there's some dark lines here, and those are astronaut footprints that are still there. So because there are no weathering processes on the moon, so these don't get erased. Again, I'll talk a little bit more about these landing sites in a bit because I actually study these, but I just really wanted to show off what our cameras are capable of. All right, so I'm going to move into some discoveries and science results from LROC specifically, although a lot of the different instruments are incorporated into some of these. So is this animation working? Yeah. All right, so one really great thing, so LRO has been in orbit now since 2009, so 7 years almost. And because of this, we have images of the same area taken at different times. And we've been able to use these images to detect new craters, which is what you're seeing here in this animation. This one was, I think, March 17th of 2012. It was a pretty big one. This one is about I don't remember the exact size of this one, but more than 10 of the craters we've identified are larger than 10 meters, which is about 32 feet, which is about 5.5. What's the actor in Pirates of the Caribbean?
Johnny Depp.
Johnny Depp's, yes. So I had his image in my head. So they're fairly large. They're not giant craters by any means, but we have discovered over 140 new craters, which is giving us information into how often the moon is impacted. And this is just another picture. You'll see a before image and then an after of a new impact here. So we have people working on identifying these. All right, and then volcanism, I will talk briefly about. So this has been a really important result from LRO, this idea of young volcanism. So I say young because it might not seem that young to you guys, but in geological history it is. So previously, before this mission, we thought that volcanism on the moon ended about 3 billion years ago. But our images have revealed features that may be 1 billion years old, created by volcanism, or maybe even as young as 100 million years old. So again, this might not seem real young to you, but in geological history it is. So we always say the moon is dead, but the moon might not have been as dead for as long as we thought. And we're able to tell that these are young because if you look at this feature here, you'll notice there's not a lot of craters on it. So if you look at a surface on the moon and it doesn't have a lot of craters, that probably means it's pretty young because it hasn't been impacted for as long as other surfaces. We call these features irregular margay patches, or IMPs, which I think is a pretty fun acronym. They're thought to be remnants of small volcanic basaltic eruptions that formed about 1 billion years ago or so. But we really don't know their exact age. We know they don't have a lot of craters, and we have people who've made models that can kind of figure out how old these might be. But the only way we're going to know for sure is if we bring back samples or send a rover or even humans to one of these destinations to find out more information. So the LRO orbits around the poles, the north and south pole of the moon. So here I'm showing one of the poles. I think this one's the south pole. So these are important because there are craters at the poles that never see sunlight. They're always in shadow, which means they're very, very cold and could possibly hold water within the crater or under the surface of the crater. And we've actually been able to detect the signature for water. And these are also important for future humans because if we could send humans there and extract some of this water, then we could use it as a resource that we could live off of. So this has been another really interesting, exciting result. I want to talk about moon tattoos, or swirls. We call them this because they look like swirls. And I have another one of these also up here that you guys can come look at. So these are really unique features. We don't know how they formed. People will fight over these ideas because just nobody knows. There's a few theories. There are some people who suggest that maybe a comet impacted the moon and kind of made these little swirly features. Possibly there's some little magnetic field right there that's keeping the sun's rays from weathering the surface and then making them brighter. Maybe there's different particles, there's electrostatics sorting particle sizes and making them different. All we know is they're flat, they're smooth, so it's not a topography thing. But again, we won't know until somebody goes there and brings back some samples and actually walks around and tells us what's going on. So this swirl is called Reiner Gamma. It's one of the most popular ones. It's the one I have printed out here. Here's kind of a color image that someone created of it to because we can use color to extract different properties about the moon. So there's a lot of people working on this right now, especially now that we have really high resolution images of these features. We knew they existed before LRO, but now we're finding out just how many are on the moon. All right, so now I'll talk kind of briefly about some of the stuff I actually do, and which are also some discoveries that LROC has been making. Does anyone know what this image is? Have you really, a rill? It is a rill. So this is the Apollo 17 landing site, which someone mentioned there's a rill right here. So they landed, I think, somewhere over in here, and they went over to the rill and got samples and walked around in this kind of valley-looking area. One of the neat things I've got to do with my work is I've actually got to interact with several of the Apollo astronauts, including Jack Schmitt, who was on this mission. And we had, I don't think it's active anymore, we had this virtual reality room in our department where we could put images like this in 3D, and they projected them on the floor and the ceiling and the walls, and it felt like you were walking on the surface. We took Jack Schmitt in and flew him over his landing site, and he pointed out every single feature, remembered every place where he'd gathered a sample or touched a rock. So that was a really neat experience, but that's not actually what I'm going to talk about. It was just cool. So first we need to pause, and I need to give you guys a really short geology lesson if you think you can handle it. Where's my moon globe? All right, does anyone know why when you look at the moon there's some really dark areas and some really bright areas? You can just shout it out.
Like oceans.
Kind of like oceans.
High mountains.
Yeah, so there are high mountains. So these flat areas, this is the side of the moon you guys are used to seeing. So you're used to seeing a lot of these dark, flat areas. These are actually remnants of old lava flows. So these were created when the impacts happened, basically cracked the surface, and whatever magma was inside the ocean just kind of spilled out. There's no like volcanoes on the moon, but there is lava, which is now since cooled and hardened, and created these dark, flat features. And the bright stuff that you see here is just remnants of the original crust of the moon. So the dark basaltic things that you see are made of several different minerals that are fairly dark. We have stuff like olivine up here. You guys can come look at any of these later. This is a little more green and black. We have pyroxenes, which, as you can see, are very dark and black as well. And then this is actually a basalt sample. So basically, those large areas you're seeing look like this. It's just rocks like this, pretty dark, very full of iron and things like that. But then the crust of the moon, the really bright areas, are made of feldspars, which, as you can see, are pretty white, pretty light. So very stark color difference there. So that kind of, I just wanted to run through that really quickly, because what I'm going to talk to you about, one of the things I study, is silicic volcanism. So this is a form of volcanism that's very rare on the moon, and it doesn't result in these black basaltic things like you see here. It results in things that are more this color. So these have a lot of silica, or like quartz you might think of as something that's silica rich, which is this white mineral here. So what I do is I actually study reflectance properties of the moon. So like I just showed you, there's areas that are really dark, there's areas that are really bright. So I try to figure out like why. What is it made of that makes it different in color and reflectance? Is it a surface property? Like what's going on? So this is one of the areas I study. This is an example of one of these silicic volcanic features here. They're usually these large kind of dome features that are really bright compared to the surroundings. So again, this is a really rare type of volcanism on the moon. There's even evidence from some explosive volcanism. We call these pyroclastics. Basically, they kind of make really glassy kind of materials. And again, these are very bright features. Here's a few of them here. I know the contrast is a little hard for you guys to see. This one's like an arrowhead-shaped feature. We got some domes. So I study these. I study the NAC images. So what are they made of? So my work has kind of shown that these features are most likely similar to granites, which we do have here on Earth. So these light features you guys will see. Or possibly rhyolites, which is like this rock here. Basically, this has a little more iron than this does, so it's a little darker. So these features are basically mixtures of these kinds of minerals, we think. But again, we won't really know for sure until we bring back a sample and study it. So we really need to send some robots or humans there. And again, here's another just pretty NAC image showing off some of these dome features at one of these sites. All right, so now we'll talk a little bit more about these landing sites that I showed you guys a little bit earlier. So this is my favorite landing site. This is Apollo 12, which landed here on the edge of a crater. And right here, this dot that you could see if you were closer, I have a printout of this as well. This is Surveyor 3. This spacecraft was launched a few years before the Apollo missions just to kind of test and see, like, can we land on the moon? What's the surface like? Will this be safe? So Apollo 12 landed just right across this crater from this, just to prove to the Russians that we could do what we call a pinpoint landing, that we could say, hey, we're going to land on this spot, and we can actually do that. So they said, we're going to land next to Surveyor 3. So they did it. And while they were there, they brought back some pieces of that spacecraft to kind of test to see what had happened to it over time being in the lunar environment. That's not what I study again, though. That's just a side note. So what I actually study is the area right around the lander, which I will show in the next slide a better example of. And again, here's the lander again with the little footprints. Sorry, that guy's kind of covering up some of them, but we know that rocket exhaust during these missions interacts with the surface. It sends soil spraying everywhere, but it actually creates this region right around the lander that's brighter than the surroundings. We call these blast zones, which you can kind of see outlined in a few of these pictures down here. And we know from this Surveyor mission, which is shown here, Surveyor and Apollo 12, that the Surveyor spacecraft was actually sandblasted by the Apollo 12 landing. So it got hit by all these particles that were blown when the spacecraft landed. So, oh, here we go. There we go. There's a better image. So I study all of the spacecraft landing sites on the moon. So we've got Apollo landers. We have Luna, which were the Russian landers. We have the Surveyor ones that were sent before Apollo. And then how many of you guys knew that China sent a lander to the moon a couple years ago? Yeah, so that was pretty exciting. So we've got the Chinese lander here. So I study all of those. There are several questions that I've been trying to answer by looking at these images of these blast zones. So I want to know, like, how big are they, first off? How much soil was affected? How does the reflectance vary between the blast zone and these other areas that weren't disturbed in the background? And then what do these variations actually tell us about changes in the surface properties at the landing sites? And then this Chinese landing site, which I'll show you here in a second, this actually landed after LRO had already been in orbit. And we wanted to know how did the blast zones there compare to these really old 40 to 50-year-old landing sites? Let's see if this animation works. Oh, I have to do it myself. So this was before the Chang'e 3 landing. This was taken by LRO, and this is after. So we actually have images we can directly compare of this landing and measure exactly how much the reflectance changed and how much soil was disturbed, and then compare this with what we see at the old landing sites to see if there's been any weathering, if the reflectance has changed at all. So some of the key things that have come out of my work with this is we know that the reflectance at these landing sites was increased by smoothing of the surface. So the rocket exhaust kind of smoothed out the surface when the lander went down. Also changes in grain size. So there's actually finer particles probably in this bright area. And these things have been really important because they help us plan for future missions. And I skipped over this bullet point, but we actually find that the blast zone at the Chang'e 3 landing site is pretty much the same as the others. So they haven't changed in the course of 40 to 50 years. So we use this to help us make predictions for future landings on how much soil will be disturbed when we land on the moon, whether this will be dangerous to the spacecraft or to anything in the nearby area. It kind of helps us determine, okay, we have a spacecraft this big, how much soil will we disturb, how far away should we land from certain features, what should we do to protect our spacecraft? If we want to take a sample, do we need to go away from this disturbed area? So these are kind of things that I'm working on with my work. All right, so the moon. I just showed you some of the discoveries that LRO has made. I've said we need to send humans back, but like why? I mean, yeah, sure, it'd be cool to like know what this swirl is made of, but what are some bigger picture reasons of going back? So first off, just continued exploration. Again, it's ingrained in us as human beings to explore. So why not? Why not explore? The moon is a great stepping stone to Mars. I think if you ask anyone in the moon community, we'll all tell you we love the moon, but the idea is to get to Mars. We want to go back, but we want to go back so we can figure out how to go even farther. So we can use the moon for several things for that purpose. Technology development, again, there's a lot of things we need before we're able to go to Mars, and the moon is a really good place to learn and practice and to develop these technologies. We can also use the moon as a refueling station. So you'll see on this list over here, we can do a lot of resource harvesting on the moon. We can actually use the soil to get oxygen, to make water, and to make fuel. Hydrogen and oxygen are the two main components of a lot of rocket fuels, and we have those in abundance on the moon. So there's actually people who are working on developing these things now. And it actually takes a lot less fuel to launch off the moon than it does off Earth. Anyone know why? Gravity, yeah, so gravity, no atmosphere, lower gravity, it's a lot cheaper, so it's cost effective. And then if we send humans to the moon for long periods of time, we can learn what it does to our bodies before we send anyone to Mars. And then again, just to build some kind of permanent or semi-permanent architecture so we know what it's really like to live in space for a long period of time. Again, I think I mentioned this earlier, we can do a lot of science from the moon. There's a lot of like radio astronomy that can be done because there's no atmosphere on Earth. Anybody who does radio astronomy has got to worry about this silly thing called the atmosphere, but we don't have that on the moon. So it's a really great place to do kind of astronomy type studies. We still have a lot of unanswered questions about the moon. We have not covered a lot of ground. All the missions to the moon have been about right here. We still have all of this left to explore. So if anyone tells you we've been there, done that, don't believe them, because there's a lot that we haven't been to. So there's a lot of questions that are left to be answered. We still want to understand the presence of water and different kind of resources on the moon, and we still need to learn a lot more about impact processes. The moon is actually a really good opportunity for international collaboration. There's a lot of countries who are interested in the moon, China, Korea, India, the US, Russia. So this is a really good opportunity for us to work together for a common goal. And then location, location, location. Like the moon is right there in our backyard. It's easy to get to. And I really like this quote by Jim Bell, asking if people will go back to the moon or visit the asteroids or travel to Mars and beyond is academic. We will and we must, or else we'll stop seeking answers to the bigger questions. We'd stop being explorers, we'd stop being human. To the moon, Alice, you betcha, it's in our genes. So I've kind of hit on this a little bit, and I won't go into depth because this isn't really my field, but again, there's a lot we can use the moon's resources for. We can use them for construction materials. So there's actually people who are looking at using the actual soil on the moon, which we call regolith, as a habitat protection. So if you can kind of cover your habitat with this, then perhaps you can protect against some of the radiation in space. We can actually build landing pads with the lunar soil. I've worked with some guys who are working on this, like flattening out the soil and doing things to it to make it a safe landing pad, and building different pathways and things. Again, making oxygen from some of the rocks, which is a project called Roxygen. It's kind of clever. Making water or using water on the moon, and again, rocket propellant. So how many people would live on the moon if given the chance? Some of you guys would do it? Yeah. So this is another discovery from LRO that I'm kind of throwing in here at the end. So these were imaged in various areas on the moon. It's essentially a hole looking down underground. So actually this area that's lit up is actually underground, is what you're seeing here. This is a lava tube. Here's an example of a lava tube in Hawaii. So this is basically just an area where lava used to flow under the surface, and now it's hollowed out. But this could be our future home. There's no radiation, there's no little impacts happening down here, there's no extreme temperature swings. So this is really ideal to send people to live and work one day. So there are people who are actively looking at this, looking at sending some kind of robotic spacecraft to go and fly around in one of these and look around and see how stable it is. So these are pretty interesting. All right, so why explore? Why do we need a human presence in space? So again, it would really help us to understand our place in the universe, understand the history of our solar system, tell us if we're alone. It will enable new technologies that make life on Earth better. A lot of these technologies that are developed for space, we use in our everyday lives here. It will help us to foster peaceful relations and cooperations with other nations. And then it's challenging, rewarding, and part of who we are. And again, another quote by Jim Bell, that robots will never replace the need for human space exploration. And so that's the end of my talk. I usually like to kind of end, I know there's a lot of young people in the room, and one part of my story that I left out. So I grew up in South Carolina, well, half Indiana, half South Carolina, but I went to high school in South Carolina. And when I told people I wanted to be an astronaut, I got made fun of, to the point where, to this day, I hesitate to tell people what I want to do because I'm afraid they'll laugh at me. But I also didn't let that stand in my way. I went to a high school where we had about 800 people in my graduating class. 2 of them left the state for college because everyone thought, I can't go anywhere, I can't do anything other than stay here and stay in my little box, which is fine for some people, no problem in like not moving away from home or anything. It was hard to move away from home, but for me to follow my dream, I had to do things that were hard, despite what people were saying to me. So I really like to encourage people that it's going to be hard along the way, but if you have a dream or you have a goal, don't let anyone get in your way. And if anyone wants to talk to me about like anything related to that, don't ever feel like your dreams are too big, because it's not always going to be easy, but it's incredibly rewarding. So just don't let anyone stand in your way. Those people don't laugh anymore, I can tell you that. So with that, I just want to end and say, let's go back to the moon. Thank you.
This is my favorite part. This is where we get to ask her as many questions as we want. So let's take advantage of this and just raise your hand and start. All right, somebody's starting it off. Let's do it right here.
So, Apollo 17 landing site, Schmidt discovered the famous orange soil.
Yep.
I don't remember, I guess it was some type of volcanic.
Yeah.
So, in your studies, have you found a similar, whatever that was, have you found it at other places?
Yeah, so that was one of these examples of explosive volcanism or pyroclastics that he found. And some of these silicic areas I look at, we do have evidence for these pyroclastics. I don't know that they're necessarily the orange color. They have the orange ones and the green ones and the black ones. These are probably more white or clear. But yeah, we have seen similar things. So.
It seems like there's more craters or more things hitting the moon than the Earth. Why is that?
It's the atmosphere on the Earth will disintegrate most of them before they get hit. The big ones will make it through on Earth. We do have craters here. Another thing on Earth, because we have weathering, a lot of them are just erased over time, so we don't see them. But the atmosphere is a large part of it. So, yes.
So my daughter is interested in a space career, and when I've mentioned that to people, they're like, it isn't like kind of all over. There's nothing going on, but obviously
it's not true.
Yeah.
Yeah.
So do you think the career prospects in space sciences generally is positive and growing? And
yeah, I mean, it kind of fluctuates year to year depending on the government's funding and everything. But yeah, I mean, there's still, I get this question a lot, like, but isn't there, there's nothing going on, right? I'm like, no, there's a lot going on. There's still a lot of people that are interested in it. We've got, obviously, the stuff going on with the moon. There's a lot going on with Mars. There's a lot more that's going to be going on with Mars. We have the outer planets now. There's Pluto's big. The government just asked us to send a mission to somewhere like Europa or something to look for these oceans and ocean life. Yeah, so the career prospects are fine. And there's so many different things you can do. I do research. There's people who design missions. There are people who fly on the missions. There are people who do more public kind of outreach things. We've got engineers, pilots, physicists, chemists, mathematicians, you name it. There's usually a place for you in the space industry, so yeah.
Ryan, what about SpaceX?
Yeah, oh yeah. Sorry, I didn't even touch on private. Sorry, I do NASA stuff, so I tend to not talk as much about the private stuff, but yeah. So SpaceX is a big one right now. Some of you might have seen they just landed a rocket on a barge. They're trying to get a Mars program going. There's other private companies that are doing similar things. None of them have been quite as successful as SpaceX, but those are, yeah, the commercial industry is a big place right now too.
What's the tallest mountain on the moon, and how high is it compared to our mountains?
Yeah, I used to know the answer to this question. I can't tell you where it's at. Let me see if I got this little guy. So the tallest ones here are on the far side, and I want to say they're about 10,000 meters. So they're comparable to what we have on Earth. I don't think there's anything that's necessarily bigger than Everest or anything, but they are pretty tall. But I can't give you an exact number off the top of my head. So you're welcome to come look at this in a little bit if you want and just kind of see, but most of them are right here. So.
We've got a young kid back there.
Yes.
Wait, you in the back, yeah. Yeah, speed up.
I don't know if I will build it, but I do know there are a lot of people at NASA who are working on something like that. There's no plan to do it right now, but there are people who would like to and are developing things that could build a space station on the moon, yes.
You should build it. Yeah.
Yeah.
You should do it.
I mean, I firmly believe that my generation will see somebody land on Mars. I think we should go to the moon to get there, but I think that it will be led by your generation. So, yeah.
You were talking about space tourism. They landed on the moon, right?
They just went to space. They didn't land on the moon. They just went in orbit around the Earth. But there are companies who want to send tourists to the moon, yes.
People buy.
Yeah, they buy tickets, yeah. So they're rich. Yeah. Yes.
So have you been able to verify how many of the flags are still standing at the landing site?
Yeah, I think most of them still are. Let me go back to my picture real quick. I'm not sure if you can see it in this one, but we can see their shadow in several of these pictures. It'd be easier if I do this. Oh, animations. Maybe I can't pull it up, but I'll show you on one of my landing site pictures over here. But yeah, we can see them and they are still standing. We think that the little American flag part of it is probably kind of bleached out by now. It's probably just like a white square, but they're still there, yeah.
So I think Apollo 11, there's some questions of whether or not that's actually correct.
Yeah, they think there is one that they think fell down. I don't remember off the top of my head which one it is.
Buzz thinks that he saw it.
Yeah, so this one, let's see if the flag is labeled here. Nope. So it might be that one, yeah.
What's the latest idea as to why there's no Mara in the backside? I heard this new theory that there was a large slow-speed impact. The other day that was boiled off and the moon was closer and we got deposited in the back. Yeah,
I've heard both those things. We don't really know why the crust is thicker.
I heard the boil-off was impossible.
Yeah, there's some of them that are kind of weird. I heard one that was like an impactor just kind of mushed into the moon, and yeah, so that's still a question to be answered, and yeah. Yes?
From your point of view, that black and white image have what kind of advantage compared with the color?
It kind of depends on what you want to do. For me, since all I study is brightness changes, black and white is just fine. There are other people who want to dive a little more into composition or some other physical properties that you kind of need color for. So there are advantages to color, but the moon is a black and white place. So yeah, I mean the moon is basically that color.
So that's a true color, or it's just?
I mean that's a little false, but for the most part, it's just gray and black. You'll find a couple things with color, but for the most part, studying black and white is just fine for the moon, which makes it cheaper to build cameras because you don't need color. But yeah.
I think this gentleman right here has been trying.
Yeah, go ahead.
I was just curious how your LRO got there. Was it like on a ULA rocket or was it on a Russian rocket?
No, it was American. I don't remember if it was ULA or not. It was launched from Cape Canaveral in Florida, so it was all American at that point.
There's other stuff that went up with it.
Yeah, so there was another spacecraft that was launched at the same time called LCROSS. I don't remember what that stands for, but it was basically just a spacecraft that was designed to impact into the pole at the moon, and then LRO actually followed behind it. So LCROSS impacted, sent off a spray of stuff. LRO flew into the spray and tried to detect if there was water, and they did detect some. So those two were launched together. Yeah. Yes.
Now, this is a question about the future, but do you envision sometime down the road where people will own real estate and it'll turn into a real estate market on the moon?
We'll see. There's basically a treaty out right now that says no one owns the moon. So they're going to kind of have to work around that. But it's very possible. I know that there's, you can go on websites that are like selling plots on the moon or Mars. So it could very well become something, once there's more capabilities and more countries are going there, it could turn into something like, yeah.
So we got one.
Yes?
So there are a lot of like backyard small corporation rocketeers now. So like, do you know how far the government allows people to send up rockets? Like, can they go all the way into space? Because they can just go all the way to the Earth's space boundary.
Yeah. I mean, I don't think we own space, so really, I don't know if there's like aviation laws or anything for some of that, but.
There were laws that were like saying you can only go up 11 miles a while ago.
Yeah, I don't really know as much about that. There might be something, but I don't know off the top of my head. Yes, Christine.
Hi, Ryan. I just am so impressed with how many people are here so interested about the moon and space. And I just have to mention that there's an organization in St. Louis called St. Louis Space Frontier that focuses on living and working in space and space exploration. So if any of you are interested further, please check us out online. It's St. Louis Space Frontier.
Yeah, and even for the students in here, there's a lot of programs through NASA and other places that have things for elementary school students, middle school, high school. I actually mentored a high school team this past year that was doing a project studying asteroids. There were other teams studying the moon, and that was all remote. You didn't even have to be in St. Louis. So if you're interested in anything like that, come talk to me. I'll give you my email address or something and send you on some information. So
Didn't think to bring my...
Yeah, or talk to Christine. She's got more of the information for that. So yeah. Yes.
So, a lot of things have impacted on the moon. Like all the boosters that took the Apollos up there, a lot of them.
Yep.
Do we know, have you guys located all those
Yes.
things now? And you've studied, I would imagine.
Yeah. So if you guys go to the Lunar Reconnaissance Orbiter Camera website, I know that's kind of a lot of words, but just Google it. You can find our website. We have a whole page for featured sites where we have all of the spacecraft landing sites, both human and robotic. We have the places where all of the old boosters have impacted. We even have like new impact sites listed there. So yeah, we've located just about all those. So yeah.
Okay, so I think we'll save any other questions. You can catch her before she leaves.
And come touch the meteorites and other things. So it's all to be touched.
Before that, let's thank our speaker one more time.